All right, today we're going to start working with the second derivative test. And this is a great test if you have functions that you can get a first and second derivative fairly easily. But I want you to notice something here. This should look familiar. This is our critical point. If we find a critical point and we plug it into the second derivative and we get a positive value, then it's a minimum. So I want you to realize you have to think opposite here. It's not what you would think. But if we get a positive value, it's a minimum. And the second part says that if we get a negative value, it's a maximum. So once again, think opposite, and then it's a really nice test. When can I use the second derivative test? Well, we have to have a critical point. And f prime of that critical point has to be 0. Okay? The tangent line to f of x must have a slope of 0, and x equals a cannot be an undefined slope. Notice, if we happen to plug in the critical point into the second derivative and get 0, then the test is inconclusive. So there are some cases where this test doesn't work, but other than that, it works out great. Okay? Let's take a look at this problem and work through using the second derivative test. All right? So if we take the derivative of this, f prime of x equals 3x squared minus 12. To find a critical point, we set it equal to 0. 3x squared minus 12. We're going to have 3x squared equals 12, x squared equals 4, and we get 2 and negative 2. All right, those are our critical points. And now what we do is we find the second derivative. F double prime of x is just 6x. By the way, the second derivative test works great with polynomials. All right, this is a great time to use the second derivative test because it's super slick. It works really nice. So all we have to do now is plug these two values in to the second derivative. Find f double prime of 2 and find f double prime at negative 2. Obviously, when it's 2, it's going to be 12. When it's negative 2, it's going to be negative 12. The fact that this is a positive value tells me that it is a minimum. Remember, think opposite. The fact that this is a negative value automatically tells me it's a maximum. So I can find the maximum values or minimum values, of course, by just plugging the 2 in, plug this 2 into the original function, find f of 2, all right, which is going to be 8 minus 24 minus 5. That's going to be negative 21. So our minimum value happens when x is 2 and y is negative 21. Find f of negative 2. And we get negative 8 plus 24 minus 5, which is 11. So our maximum value is negative 2, 11. Once again, it's super easy. If I know my first derivative and my second derivative, and I have nice critical points, all I have to do is plug them in and look at the sign. It's that easy. Let's take a look at this problem. I do want you to notice that this function is only defined for the x is greater than 0, identified the x value of the critical point, and classified the point as a relative max, min, or neither. So we find our derivative, g prime of x, which is 4x minus 1 over x. We set that equal to 0 to find our critical points, like that. I would multiply everything here by x. So now I have 0 equals 4x squared minus 1. So that turns into 4x squared equals 1. it turns into x squared equals 1/4. So my critical points are positive 1/2 and negative 1/2. But we can eliminate this one because we're only working with the x's greater than 0. And now I need to find a second derivative. So the second derivative will be 4 plus 1 over x squared. All right, just using the power rule. So now I plug my critical point into the second derivative. Plug in my 1/2 here. 4 plus 1 over 1/2 quantity squared. All I really care about is it positive or negative? The answer is 8. It's positive, so 1/2 is the location of a minimum. Okay, it's the opposite of what you think it is. Finally, an AP type question. Selected values of a twice differentiable function h of x and its derivatives are given in the table below. Which of the following statements must be true? Well, we're talking about extrema. So first, how about when would h prime of x be equal to 0? Right here, when x is 7. H prime of x equals 0 when x equals 7. There's a critical point. All right? So let's check the second derivative there. H double prime of 7 is what? According to our table, it's negative 4. That is a negative value, which tells me that this is a max. X equals 7 is a max. Now, we cannot do this one because we don't have enough information, and we cannot do this one because there's not enough information. So our answer here is definitely C, and we will stop there for today.